Okay, so today we're talking about atomic theory for the second time. So, last time we discussed that atoms are made up of subatomic particles. And there are three subatomic particles: the proton, the neutron, and the electron. And those particles have given masses and charges, okay? So, the proton and the neutron both have a mass of 1 AMU. And AMU stands for atomic mass unit, okay? Scholars, all computers should be closed now. That's super distracting. It just distracts the heck out of me when we're doing this. Okay, so 1 atomic mass unit for each. The electron does have a mass that a particle physicist cares about and needs to know. For a chemist, that mass is 0 AMU, okay? It's so small that we just consider it 0. Electrons have a really, really tiny mass, so we don't worry about it as chemists. Protons have a charge of positive 1. Neutrons are neutrally charged. They have a charge of 0. Electrons have a charge of -1. We also know that electrons exist in energy shells, not circular orbits, and that, this is new for today, shell 1 can hold up to 2 electrons, while the second shell can hold up to 8 electrons, okay? And when we draw atomic structure diagrams, we use this symbol to represent the proton, this empty circle to represent the neutron, and this little E with a minus sign to represent the electron, okay? And so today, we're going to review the atomic structure we drew last time. Did we draw helium last time also?
Yeah.
Yeah? Okay. So I know we drew hydrogen. Did we also draw helium? Hard to say. It was just hydrogen, right? Okay, so we'll start with hydrogen, okay? And one important thing, for a neutral atom, okay, and all atoms on the periodic table are considered neutral, unless we want to specify them ourselves as ions, but what's written on the periodic table we should consider neutral. For the number of protons, you also have the same number of electrons, okay? So all these atoms are neutral, neutrally charged. That means for every proton, there is exactly 1 electron, all right? So take something like hydrogen, right? So I'll give you the full spiel on the board for hydrogen again. So hydrogen has the atomic symbol H, the atomic number 1, and an atomic mass, we'll call it 1.00, even if it's 1.01. We're going to avoid that confusion because we're not at isotopes yet. So, 1, atomic number. Okay, so this is the number of protons. Number of protons. This is our atomic symbol. It means hydrogen. This over here is our atomic mass, or our mass number, okay, which equals number of protons plus number of neutrons, okay? So for hydrogen, you know you have 1 proton, and 1 plus the number of neutrons equals 1, right? So the number of neutrons is 0. We have 0 neutrons in hydrogen. And we also know that for a neutral atom, we have to have as many electrons as we do protons. So when we draw an atomic structure diagram for hydrogen, we put 1 proton in the middle, because protons and neutrons go where? What part of the atom do protons? The nucleus, good, which is right in the middle of the atom, okay? The nucleus. And we have 1 electron, right? And again, remember, this circle represents an energy level or an energy shell. It does not represent a circular orbit, okay? This electron exists in a spherical cloud around the nucleus. That's what's going on there. Okay, so, any questions about this little piece? All right, we're about to kick things up a notch. So, I'm going to actually erase the middle, and we're going to look at a different atom. And I'm going to replace, well, I don't have to erase too much, right? Let's just watch how this changes. So I'm going to erase the 1, and I'm going to erase that, right? And I'm going to give you 4.00, and I'm going to give you a 2 right there, and I'm going to put a little E next to the H. So now we're dealing with not hydrogen, but helium, okay? And where have we seen helium in our lives, or where have we experienced helium? Balloons, right? Our little helium balloons. Good, okay? And helium has an atomic number of 2, and it has a mass number of 4. So if the atomic number for helium is 2, what is that telling us? Two protons in the nucleus. All right, 1 proton here, and I'll draw another proton here. Okay, 2 protons. And then if the mass number is 4, how many neutrons do we need to add to the 2 protons to get a mass of 4?
2.
2? Is 2 plus 2 4?
Yeah.
Yeah, right? So we got to add 2 neutrons. So we'll represent them here and here like that. Okay? And then only one thing is missing. What's the last thing that's missing here?
Electron?
Electrons. How many electrons should we have?
1,
Well, we have how many protons?
2,
2. So how many electrons do we need if they have opposite charges to balance?
2.
2 electrons. Okay. So here we go, and here we go. Okay? And that is a proper atomic structure diagram for helium. Now what I want you to do is think about how the situation should change as we add an extra proton. So we're going to add 1 extra proton, and we're not going to be dealing with helium anymore.
Would that unbalance it? Like if it was, like would that unbalance the nucleus? If there was too many protons or neutrons?
Okay, so that's a really interesting question. As you add protons, you also have to add neutrons. What the neutrons do is protect the protons from one another's charge, okay? So the protons are positively charged, but the neutrons shield them electronically from each other, okay? So they don't repel and blow up. However, that effect only lasts so long, okay? So once elements get big enough, they become radioactive. What that means is they decay on their own, they blow up or they split apart on their own, all right? So things like plutonium and uranium and any of those really big elements, francium's radioactive, radon's radioactive, okay? Big elements tend to be radioactive. So what that means is there are just too many protons and neutrons in the nucleus, that nucleus is no longer stable, those things will decay radioactively, okay? They will form smaller elements. Angel?
Is there any like type of chemical that is like, chemically unbalanced but it can still work, or is there like is there always a balance between the chemical of the nucleus, the electrons and protons?
There are some big elements that are not radioactive. Yep. Okay, does that answer your question?
Yeah.
Okay. So now we're going to try something else. We're going to take a look at lithium. So I'm going to erase this, and we're going to look at a different example. And that example is lithium. So lithium looks different from helium and hydrogen. Lithium, symbol Li, has an atomic number of 3 and a mass number of 7.00. So what I want you to do is think about what it means that we have a 3 here. What does the 3 tell us?
Atomic number.
3 what? 3 protons, and then we're also going to balance those with what? 3 electrons. Okay, 3 electrons and 3 protons, good. And then 3 plus what gives us 7? 3 plus 4 gives us 7, so how many neutrons do we have? 4, okay? So, we've got 3 protons, 1, 2, 3, and then 3 neutrons. We got to add a 4th neutron right here. And then we have 3 electrons to balance that. But remember, for a neutral atom, okay, or sorry, remember, shell 1 can only hold 2 electrons. So what do we have to hold the 3rd electron? An additional shell. Exactly, very good, Kaylee. So you go here, here, shell 1 for the first 2 electrons, and then we just add another one over here, and a whole new shell. Okay? And that's how we diagram that out.
So only 2 can be on a certain shell, like on one shell?
Only 2 can be in the first shell. This second shell can actually hold 8. And we're going to learn why that's the case in the coming weeks, okay? We might even get there next week. So for now, this is a good diagram for lithium, okay? So your challenge, and I'll go ahead and stop the recording at this point because really we're just extending this concept out and we'll go over, this concept again in further lectures. So I'm going to stop the recording at this point. But the thing that I want you to solve, and I'll go ahead and erase this, I want you to show an atomic structure diagram for this guy, beryllium. So beryllium has an atomic number of 4, a mass number of 9, and the symbol Be, okay? Beryllium. Go ahead and draw an atomic structure diagram for that guy. Everybody should be drawing, right? Because everybody understands, okay? We're doing a really good job.